All right, so let us start with chapter 10 today. So chapter 10 is about wave. So it's quite similar to simple harmonic motion, but it's not exactly the same. Simple harmonic motions, you look at the path traveled by an object, which is a periodic motion that is going back and forth, that is going up and down. Okay, it's a periodic motion. That means it keep repeating the same path. But when it comes to wave, okay, wave is not about how an object moves. It's about how the energy is being transferred from one point to the other point. Okay, so how does it transfer energy? So now you're still having the shape of the wave. Okay, so you have one object. This is your initial object. So energy is being exerted at this point, at this position. So what happened? Now it will pass the energy to the next particles. This particle will then pass to the next particles, and all these particles, they are oscillating. They are oscillating up and down. Okay, they are not going towards any other direction. So they are oscillating up and down, and eventually you will see a wave shape here. Okay, so they keep passing on the energy. So what happens right now? Now this is still your equilibrium position. Okay, but now this object is oscillating. Okay, it's oscillating, it's oscillating. All right, so every particle is oscillating up and down. So you don't look at it as a whole, you look at it as a set of particles. So all these particles, they are all moving with different amplitude where the energy being passed to them. So they're oscillating up and down, and then you will see that the wave is like it is moving to the right-hand side or it is moving to the left-hand side. So remember, if your wave is moving to the right-hand side, then in your equations, you are going to use negative sign. Okay, if wave is going to the right, then you have y equals to a sine and then omega t minus kx. If your wave is traveling to the left, okay, if your energy is being exerted at this point, okay, it's at this point, then the equations will be y equals to a sine omega t plus kx. So you have two different equations for two different directions. So the direction tells you, the sign convention tells you the directions of the energy being transferred. So this is what we have to use, the equations that we have to use in our questions. And of course, you must know the sign convention, which sign convention to be used. Because some of the questions, sometimes they will ask you to form equation. Okay, questions give you a scenario. Now you have a wave traveling to the right-hand side. So form an equation to represent the wave. Okay, then in that case, you need to know, since your wave is traveling to the right-hand side, then the equation should be negative. So if your wave is going to the left, then the equations that you form must be a positive equations. All right, so this is the general equation. So of course, you have two types of motion. Okay, these diagrams that I show, it shows you the motions of the particles. And when you look at it as a whole, as a wave, so it will just like travelings, okay, travelings, a wave that is keep moving. Okay, the moving to the right or to the left, depends on the directions of energy transfer. So there are two types of motions that we're going to look at. One is what we call wave motion, and one is what we call particles motion. So particles motion is very similar to simple harmonic motion. Okay, so when it comes to particles, every particles, they are moving with simple harmonic motion. Why? Because they are oscillating up and down around their equilibrium position. So that is a form of periodic motion. So when it comes to particles, when you look at the particles, then we say particle is moving with simple harmonic motion, and therefore the equations, okay, the equations for x, for v, for a, all we use equations of simple harmonic motion, okay, equations of SHM. But when you look at it in terms of wave, okay, if you treat it as a wave, then we have a new equations, especially when we calculate the velocity, we have v equals to f lambda. All right, now v equals to f lambda, last time got students asked me which term is constant. It depends on the questions. If you're looking at the particle traveling in the same wave, okay, traveling in the same wave, then the speed is a constant. So if you change the lambda, then frequency will change. But if you're looking at now, you want to transfer the energy from one medium to another medium, then we keep the frequency constant. So in that case, your v and lambda, they will change with each other. All right. So actually, it depends on what is the constant variables in our scenario given. Some scenario, if they keep f constant, then V is proportional to wavelength. Now, in some scenario where V is constant, if you have a wave traveling in the same medium, okay, then V perhaps is a constant. For example, air. Then if you change the frequency, then lambda will change. So it depends on the scenario, the situations given. See which one is a constant variable, either the frequency or the velocity, right? So it's very simple, okay? We're just going to focus on the general equation in 10.1, which is y equals to a sine omega t plus minus kx. So now let us look at the questions. Okay, let us look at the questions. So first questions, you are given an equations. Now, as you can see here, you are given an equation, and the first job you should do, the first task you should do, compare this equation with general equation. Which equation should we use? You look at the equation. Now you have a positive sign. Okay, you have a positive sign, it means you're going to compare with a positive equation. So y equals to a sine, okay, bracket, omega t plus kx. Now again, there are three variables that you need to keep it as unknown, which is y, t, and x, okay, because it changes with time, it changes with distance. So at a different distance, your particle is located at a different displacement. Right? At a different time, your particle is located at a different displacement, like what we have been discussed in chapter 9, the simple harmonic motion. Okay, now we have amplitude. Okay, questions 1. Okay, now a progressive wave is described as y equals to 2 sine bracket 2 pi t over 0.4 plus x over over 8t. While x and y, they are in terms of cm and second. Determine the following from the wave. So we are given an equations, and when you're given an equations, the things that we should do is do the comparison. So compare with the general equation. So by comparison, we found out that amplitude A is now equals to 2. So what is the unit? Now, since your y and x, they're in terms of cm, of course, A would be in cm. So A equals to 2 cm. And then wavelength. Now, if you remember the things that I told you before, in this chapter, now previous chapter, we have one family called period, frequency, omega. They are one family. In this chapter, we have another family called k and lambda. So if questions ask you to find lambda, definitely it will give you k. If the questions ask you to find k, then you will be given lambda. Sometimes lambda can be obtained from the graph, sometimes can be calculated. So now questions ask you to calculate wavelength. So you try to identify the values of k from the equation, okay? So if you're given an equation, you identify k. You are given a graph, then you can identify lambda straight away from the graph. So now you're given a k, you're given an equation, so you need to find k. What is the values of k? Now this is the part where you have to be extra careful, all right? So if you look at these equations carefully, you have a 2 pi here. This 2 pi, actually it belongs to your omega, actually it belongs to your k. Okay, just that they factorize it out because two of them, they share the same constant, okay, they have the same value. So by comparison, my k is not only 1 over 8t, but it should be 2 pi times 1 over 8t, which is 2 pi over 8t. So this is my k. Okay, and the quantity for k, the unit for k, again, you look at the unit for x and y. X and y, they are in cm. So k is cm negative 1. Okay, k is cm negative 1. Now, how to obtain lambda from k? Well, since I say they are family, means that they must be an equations where we can link them together. So k is equals to 2 pi over lambda. All right, so at the same time, we know that this is equals to 2 pi over 8t. So rearrange equation, okay, rearrange this part of the equations, you will obtain lambda equals to 8t. And what is the unit? Since my k is cm negative 1, my lambda would be in terms of cm. So this is how we determine the unit for every single quantity in our questions, in our equations. Okay, you look at the unit for x and y, then from there, you should be able to determine the unit for wavelength, you should be able to determine the unit for omega, and so on. Okay, so next one, frequency. So we have A, we have K. Now we want to determine the frequency. If you look at the information that I give you just now, frequency is coming from another family. All right. So if you're given t, you can determine frequency. If you have omega, you can determine frequency. So by comparisons, we will get frequency, or we'll get omega from the equations, okay, the values of omega from the equations given. So omega, again, it is not just equals to 1 over 0.4, but you don't forget about this 2 pi. Omega is actually equals to 2 pi times 1 over 0.4. So it is 2 pi over 0.4. All right, so radians per second. So what is the equations that we should use to get the values for frequency? Now you look at the equations. Omega at the same time is equal to 2 pi f. Okay, so we know 2 pi over 0.4 is equals to 2 pi f. So rearrange the equations, you will obtain f equals to 2.5 hertz. Okay, 2.5 hertz. So that is how we obtain the value by comparisons. So whenever you're given an equation, the first thing that you should do is to do the comparison. Compare between the equations given and also with the general equations. Okay, and also with the general equations. Okay, now the last question, the speed. Now this one, okay, this one, the speed, sometimes students, they get confused. Okay, whether you should determine the speed for the wave or speed for the particles. Then you go back to the main question. So if you look at the main question, it asks you to determine the following from the wave, which means question is asking for wave speed. Okay, wave speed. So wave speed, you don't have to use the equation from chapter 9. Equation for chapter 9 is for the speed of particle. Okay, the speed of particles at different time, at different position. Now, when it comes to wave speed, all waves, they only come with one speed initially, unless you have an external force exerted on it, unless you change the speed with an external factor. Okay, otherwise, all waves, they are going to travel with the same constant speed, while it can be calculated by using f lambda. Okay, so your v is equals to f lambda. So you have f from a third question, lambda from the second question. Straight away, you will be able to determine the wave speed. So 2.5 times, now remember, change it into SI unit. Okay, 0.8 meter. Therefore, you obtain 2 meter per second. Okay, 2 meter per second. So that is how you solve questions 1A. So I give you 2 minutes to write it down, okay, before we proceed to the next question, because 1B is slightly complicated. So make sure you understand 1A first, okay? You try to go through 1A as a form of revision. So if there's any questions, please ask before we proceed to the next question. Okay, so kamu tengok dulu soalan 1A. Pastikan Anda faham, Anda catat dulu sebelum kita proceed bergerak ke soalan 1B, sebab B dia rumit sedikit. Alright, 2 minit bagi Anda catat dan tanya sekiranya ada soalan. All right, so 1A, that's it. Very simple, very straightforward questions. You can solve it by comparisons. So now let's look at 1B. For wave shown in A, determines the maximum value of dy over dt at x equals 0. What does this value stand for? So this question itself, it consists of 2 pieces of information. First thing, it is asking for the value of dy over dt at x equals 0. Second thing, it is asking for the maximum value of dy over dt at x equals to 0. So let us solve it part by part. Okay, so I'm going to call this step 1 and I'm going to call this step 2. So let us begin with step 1. So step 1, okay, now you want to calculate the values of dy over dt at x equals to 0. If you remember the things that I told you before, whenever you are given a value, you just have to substitute it into the equations given. So we are given an equations y equals to 2 sine and then 2 pi t over 0.4 plus x over 8t. Okay, so this is the equations given. So the first things that we need to do, we need to differentiate this equation because the question is asking for dy over dt. So you differentiate this equation, you will obtain, okay, dy over dt. Now you differentiate it with respect to time. Okay, so what are you going to do? You're going to move the omega to the front of the equation. So basically it's very simple. Okay, I'm going to show you some extra information first before we proceed to the solution. So if you're given an equation, for example, y equals to a sine omega t plus kx, okay, for example, and you want to differentiate with respect to time. So d over dt would be equals to a omega cos omega t plus kx. Okay, you move the cos to the front part because it comes with a t. Okay, because there's a t here. Now, if you're going to differentiate it with respect to the x, so if you want to calculate dy over dx, then it will be ak cos omega t plus kx. All right, that is because of the x right here. So you move k to the front, okay, to the front of the trigo functions, to the front of the cos function. So now you have dy over dt. Okay, so we are going to stick to the first one. So dy over dt is equals to a omega. So I have 2 times omega given is 2 pi over 0.40. Okay, 0.40. So 2 pi over 0.40. Then cos 2 pi t over 0.40 plus x over 8t. So this is the equations after we differentiate it. Okay, we take omegas out. So this is our omega. Okay, this is the omega. Why? Because now you differentiate with respect to t. So you take the constant of the t out and put it at the front of the trigo function. So if you differentiate x, then you take k out. Okay, you put k in front of the trigo functions. So dy over dt, now we obtain a new equations. So what are we going to do right now? Let us simplify it first. So dy over dt is equals to tan pi, okay, tan pi cos 2 pi t over 0.4 plus x over 8t. Okay, so this is the equations of dy over dt. So now that you have dy over dt, next one, what you should do is you substitute x equals to 0 into the equation. That is the first step. Values of dy over dt at x equals to 0. So dy over dt at x equals to 0, okay, when x equals to 0, dy over dt is actually equals to tan pi cos 2 pi t over 0.4. That's it. Okay, that's it. So this is what happens in the step number 1, where you obtain an equations for dy over dt at x equals to 0. Now, how about maximum value? So when it comes to a trigo function, when you're talking about maximum value, we always assume this part is equals to 1 at maximum. All right, the trigo part is equals to 1 at maximum value. So V max, okay, your dy over dt max, okay, the max value, or you can call it V max because that is actually represents your velocity. So it is equals to, okay, it is equals to tan pi, okay, tan pi cm as -1. Okay, by assuming, okay, is equals to tan phi when, this is how you write it, when cos 2 pi t over 0.4 is equals to 1. So this one, okay, this part, it is valid for any equations with trigo function, not just in this chapter, but you will see this scenario, this situation, this type of questions very often in SEM 2, where you have an equations with a trigo function, and then the question asks you to determine the value at maximum position, at the maximum value. The question asks you to calculate the minimum value. Then you should know, when you have a question that asking for maximum or minimum, then we assume cos or sine, okay, cos theta or sine, we assume, okay, assume equals to 1 at maximum value. If question is asking for minimum value, then cos theta and sine theta, just this part, but not any other part. Okay, not including the amplitude, not including all the other part of the equation, just the trigo part. So cos theta and sine theta, okay, we assume it is equal to 0 at minimum value. Okay, at minimum value. So this is the concept that we're going to use very often in SEM 2, right? In SEM 2. So right now, this is just a brief intro on a tissue on telling you how to calculate value at maximum. So if question is asking for value at maximum, then you just assume the trigo part is equals to 1, which in this case, our cos 2 pi t over 4 over 0.4 is equals to 1. All right. So this part is slightly complicated. I give you some time to digest it. I give you some time to understand it. All right. So you may write it down. So this is a step 2. Right, so we have step 1 where we find the equations for dy over dt, we derive it, we differentiate it, and then after that we substitute the values given into our equations. And then the next step, you calculate the maximum value by assuming the trigo part, the cos function is equals to 1. Okay, the cos function is equals to 1. So that is the answer for questions B. Okay, I give you again 2 minutes to write it down. Okay, 2 minutes for you to write it down. All right. Okay, so if no question, let us move on to the next one. So again, next one, you see you are given an equation once again. So in chapter 10, you'll be given an equations quite often, so, all right? If not equations, then you'll be given a graph. Then you need to know how to extract the information from the equations or from the graph. So let's look at questions 2. Questions 2, again, you have a progressive wave, okay, progressive wave, the wave that is moving. It's represented by the equations y equals to 5 sine 2 pi t minus pi 2 over x. Now you're given a minus sign, then you should know your object is now moving to the right-hand side. Okay, your object is propagating to the right-hand side. So y equals to 5 sine 2 pi t minus pi over 2x. So again, we want to compare it with the general equations. Y equals to a sine omega t. Now you're given negative sign, so minus kx. All right, if you're given an equations with positive sign, then you write plus kx. If you're given an equations with negative sign, then you just write minus kx. So compare the equations given with the general equation. So by comparison, okay, you will be able to solve questions A. So questions A asks you to count how many things. Let's see. Amplitude, angular frequency, wavelength, period, frequency, wave speed, and also what is the direction of motion. 7 things in one question. And these 7 things, it consists of 2 big family. Okay, 2 big family. Remember, you have T, omega, F. This is a family 1. K and lambda. This is a second family. So you have 2 family in one questions. So first, let us solve an amplitude. What is the amplitude? So by comparisons, I have A equals to 5. So what is the unit? Again, you look at the questions. Questions tells you Y and X, they are in cm. Therefore, A is equals to 5 cm. Okay, A is equals to 5 cm. And then angular frequency omega. By comparisons, omega is equals to 2 pi radian per second. Okay, 2 pi radian per second. This is by comparisons. Wavelength. Now, if you want to calculate wavelength, you need wave number. Wave number is k. Okay, so this is your 1, this is your 2. Now let us move on to 3. 3, you want to determine wavelength, means you need k. By comparisons, I have k equals to pi over 2. Okay, pi of 2, cm negative 1. So k at the same time is equals to 2 pi over lambda. So, okay, when you combine these 2 equations, pi over 2 is equals to 2 pi over lambda. Rearranging it, lambda is then equals to 4 cm. So this is our wavelength. This is how we calculate wavelength from the equations given. So now let's look at the next one, period, number 4. So period, if you look at the family, period is coming from the family with angular frequency. Okay, so omega is equals to 2 pi over t. So omega, we have 2 pi. Okay, so 2 pi over t, it is equals to 2 pi. T is then equals to 1 second. Okay, 1 second. So this is a number 4. So number 5, again, you are going to calculate frequency. Frequency is coming from same family. Okay, so F is equals to 1 over t. Well, it's very simple. You have t equals to 1 second, therefore frequency is just equals to 1 hertz. Okay, 1 hertz. So now next one, okay, number 6, item number 6 is asking for wave speed. So wave speed, again, you're looking at wave, you're not looking at particles. Okay, if particles, you apply equations for simple harmonic motion. If you're looking at wave, then you have only one equation, which is V equals to F lambda. So we have F equals to 1, lambda is 0.04. Therefore, V is equals to 4 times 10 to the power of negative 2 meter per second. Okay, 4 times 10 to the power of negative 2 per second. Question number 6, direction. Okay, direction is going to the right because now you have a negative in the equations. So negative sign means going to the right. Positive sign means going to the left. All right, means it's moving to the left. So that is questions A. Very simple questions. Again, you can solve it by comparison. Now let's look at questions B. Okay, questions B, you have to be careful. Why? Because now it tells you how many cycles you have to draw. So sketch the displacement against distance graph for a progressive wave above in a range of 0 to 2 lambda. So which means it's asking for 2 cycles, okay, 2 complete oscillation at times t equals to 0. So how are we going to solve it? if you are given times, okay, t is given, then we are going to sketch y against x graph. If x is given, then we sketch y against t graph. So how are we going to solve it? Again, look at the equation. Equation is given y is equals to 5 sine 2 pi t minus pi over 2x, right? So given t equals to 0. So like I told you before, whenever you are given a value, you sub it into the equations. So at t equals to 0 second, y is equals to 5 sine. Now, sub t equals to 0 into the equation. So you will obtain negative pi over 2x only. All right, you are left with just negative pi over 2x. This negative sign, you then take it to the front of the equation. So you will have y equals to negative 5 sine pi over 2x. All right, this is our equations. Now, if you want to plot a y against x graph, remember you need to have lambda. So how are we going to calculate lambda? Well, we have it in the previous questions already, right? So we have lambda equals to 4 cm, right? So from questions A, we know lambda is equals to 4 cm. So now let us move on to the graph. So how are we going to sketch a graph? So y against x. So the unit given is in terms of cm. So we label it as cm here. So it's going to start from 0. How do I know it start from 0? By looking at this equation. You have an equation without initial phase angle, right? So this is a sine function. But again, be careful. Why? Because it's a negative sine function. So what are you going to do? You're going to sketch an inverted sine, all right? So normal sine graph is like this. When you have a negative value, then you just flip it over. So this would be the shape. Okay, but that is not enough. Why? Because according to the questions, you need to have 2 complete oscillation. So just keep proceed. Okay, keep continuing, keep moving until you have the second complete cycle. Then that is the answer. Okay, and of course, don't forget the label. So this is 0, and then the maximum value here is 5. Here is a negative 5. And then don't forget, for one cycle, it is equals to 4 cm. So second cycle is 8 cm. So that is the things that you need to label, the lambda, all right? So yeah, that's it. Okay, that is a complete answer. Okay, this is a complete answer for questions B. So the things that you need to do, okay, you sub the values given into the equation. Now the values given is t equals to 0. So you sub it into the equations and then you simplify it. And you obtain y equals to negative 5 sine pi over 2x. From here, you then sketch the shape of the graph. And remember, when you are going to sketch a y against x graph, then you need to have lambda. If question asks you to sketch y against t graph, then you need the values of period. Okay, then you need the values of period. So can you sketch the graph for, okay, now let's say I want to add one more questions. Okay, I'm going to add one questions here. What I want you to do is very simple. Okay, I want you to try it. Okay, I want you to try it. So question C. Question C, I want you to sketch a graph for 0 and then t and 2t. Okay, when your values of x is equal to 0. Okay, at x equals to 0. Okay, so this is an additional question that I want you to solve. Oops. Okay, at x equals to 0 cm. All right, now I want you to solve this question. See whether you can solve it or not. All right, see whether you can solve it or not. Okay, so I'm going to minimize it a bit. Okay, so you can try to refer to the one that we discussed just now. Okay, you try to look at questions B and think, how are you going to solve this question C? If question asks you to sketch a graph for a y against t, okay, sketch a y against t graph. Okay, sketch y against t graph. against t graph for when your x is equal to 0. Okay, so solve it. Okay, I give you 5 minutes to solve it. Okay, 5 minutes for you to go through questions B and for you to solve a question C. Right, try to think, how are you going to solve it? How are you going to sketch it? So 5 minutes from now. Well, actually, that is your questions D. Okay, you can look at questions D as well. Boleh terus jawab dalam soalan D, tak ada masalah. Okay, so let's see how to solve these questions before we go back to question C. So this question is exactly the same as questions B just now. All right, so how are you going to solve it? Sketch the displacements against time graph for particles at x equals to 0. So you're given x equals to 0 and question is asking for y against t graph. Okay, y against t graph. So first things that you need to do, okay, now you have the equations. Again, you have the equations. Y equals to 5 sine 2 pi t minus pi over 2x. All right, this is the equations. So what are you going to do now when x equals to 0? Okay, when x equals to 0, so of course you're going to solve it into the equations. So y is equals to 5 sine bracket 2 pi t minus pi over 2 times 0. So you have equations y equals to 5 sine 2 pi t. So these equations, if you look at it carefully, it's very similar to the equations in your simple harmonic motions, right? So now you're going to sketch a y against t graph. Okay, y against t. So what is the unit? Well, units given cm and second. Now, of course, if you want to sketch a y against t graph, the information that you need is period. So what is the values of period? So according to the calculations in the questions A, period is equal to 1 second. That is what we have. So now let us proceed to the graph sketching. So you look at the equation. Now this is a sine function without a negative in front of it. So what you can do right now is, okay, now sine, you have a shape like this. Okay, and again, you need to have 2 cycles. Why? Because question is asking for in between 0 until 2 times of period. So you need to make 2 cycles. Okay, you need to have 2 cycles. Cannot have more, cannot have less. Okay, if you have more than 2 cycles or less than 2 cycles, that is considered as wrong. Okay, wrong shape. 1 mark will be deducted. So now this is a 1 second. This is 2 seconds. Amplitude, again, I have 5 here. This is 0 at the equilibrium position, and this is -5. Done. This is a complete graph. Very simple questions. All you have to know is when you are given x equals to 0, you solve it into the equations and then you simplify it. Okay, and then you sketch a graph based on the equations that you already simplified. All right, so this is how you sketch it. So now let's look at question C. Question C is slightly different. Okay, question C, questions give you t equals to 0.25 t. So repeat questions B, but now you are going to repeat it for times t equals to 0.25 period. So how are you going to solve it? So let's look at equations. Okay, equations, general equations. We have y equals to 5 sine, okay, 5 sine 2 pi t minus pi over 2x. Okay, minus pi over 2x. So we have period, capital letter T equals to 1 second, according to questions A. Okay, so from A, we know T is equals to 1 second. Therefore, T equals to 0.25, capital letter T is equals to 0.25 times 1, which is 0.25 second. So question asks you to calculate a y against x graph for times t equals to 0.25 second. Okay, so now you have 0.25. You can then sub it into the equation. Okay, your t is equal to 0.25. So when t is equal to 0.25 second, y is then equals to 5 sine 2 pi 0.25 minus pi over 2x. If you simplify this equation, okay, you will get y is then equals to 5 sine and then pi over 2 minus pi 2x. Okay, minus pi over 2x. Now, this equation, okay, we cannot leave equations like this. What we need to do, we need to rearrange the equation. All right, we need to rearrange the equations. But how are we going to rearrange the equation? We need to move the part with unknown to the front. So rearrange the equation. Y is then equals to 5 sine negative pi over 2x plus pi over 2. Now again, we cannot leave equations in negative. What should we do with this negative? We want to take it out. Okay, we want to take it out. So how are we going to move it? How are we going to rearrange it? Well, it is then equals to negative 5. Okay, negative 5 sine pi over 2x minus pi over 2. All right, minus pi over 2. So you factorize it. Okay, you factorize it, you take it out. So now you have an equation with a negative value. So what should you do? Okay, what should you do? How are you going to rearrange it? Okay, so first of all, you look at the equation sign. Okay, sign with a negative. Okay, now let us look at the general shape first. Okay, let us look at the general shape first. So sign with a negative. Let us begin with sign. Okay, kita akan split menjadi 3 step. Step number 1. Let's say if you have a let's say you have y equals to a sine kx. Okay, this is an example. I'm going to assume without this one first. This one is actually your, I'm going to call it initial phase angle. Let's assume we don't have this part yet. So we have y equals to a sine kx. If you have an equation like this is a sine function. So the general shape would be like this. Okay, this is the general shape of a y against x. Step number 2. Now, provided your equation comes with an initial phase angle, so y equals to a sine kx minus pi over 2. So what are you going to do? If you have a negative sign, then you need to shift the y-axis to the left. Okay, you need to shift your y-axis to the left because of this negative sign. So if you shift it to the left and then you extrapolate the graph, the new shape would be like this. Okay, y against x. Now you shift it by how much? Pi over 2 is 90 degrees. So you shift it by 90 degrees. Now your graph will be an inverted cos graph. Okay, inverted cos. Because you have this negative, so you shift y-axis. Okay, shift y-axis because of negative sign. So negative, you shift it to the left. Okay, to the left. Shift y-axis to the left radian, which is 90 degrees. Okay, that's why your graph now have an additional 90 degrees here. Okay, this is an additional part after you shift it. So this is when you have a negative pi over 2. Now, step number 3. Okay, step number 3. Because your equations come with negative, so y equals to negative a sine kx minus pi over 2. So now that we have this graph, okay, now because of this negative sign, I'm going to flip it over. So now my complete graph, my final graph would be a cos function. Okay, so a cos function. So which means for this question, for y equals to negative 5 sine pi over 2x minus pi over 2, my graph would be like this. All right, this is y in terms of cm. This is a x in terms of cm. Okay, I have 2 oscillations. So this is 1 oscillation. And then this is 2 oscillation. Of course, it shouldn't have gap. Okay, it shouldn't have gap here. So this is a complete graph. Where now I'm going to label it. Here is 5, 0, and then this is negative 5. And then here would be lambda is what? Yeah, lambda is 4 cm just now. This is 4, so this is 8 cm. Done. Okay, this is a complete answer. This is a final answer, the complete graph for question C. So how to solve it? I show you 3 steps already. Okay, step 1, step 2, step 3. This is how we sketch graph. We start from the fundamental shape. Okay, whether you're given a sine function or a cos function. The second step, you then shift the axis. Okay, if there is an initial phase angle. So for example, this question, it comes with a negative initial phase angle. Therefore, I shift my y-axis to the left. And then third step, if you have a negative sign in front of the equations, well then, you flip the graph. Okay, you flip it over. Terbalikan dia. then that will be your final answer. Okay, if your graph don't have initial phase angle, then you just stick to step number 1. If your graph don't have initial phase angle but it come with a negative sign, then you follow step 1 and then you jump to step number 3. Okay, if your graph come with an initial phase angle and it has a negative sign in front of it, then you follow this set of recipe. Okay, start from the general equation and then try to think how you're going to shift it, and then the last step you flip it over after you shift it. That is how you solve question C. All right. So question C is quite complicated. I will give you more time to go through the solution. All right. I'll give you more time to go through the solution. So 5 minutes for you to complete question C. Okay, for you to go through it, for you to write it down, including the step. Okay, including the step. So these are the steps on how you solve it. Okay, these are the steps. So make sure you know the step. So 5 minutes for you to complete the solution. If you have any questions, you may ask.
Madam?
Yeah?
I don't understand step 2, where you actually shift the y-axis to the left.
Actually, that is the rules. I cannot tell you why.
Okay.
If you have a negative, then you shift the y-axis to the left. If you have a positive, then you shift it to the right. Now, actually, it's coming from one. It's coming from your simple harmonic motion. If you remember simple harmonic motion, I try to show you the simple harmonic motions. Let's show chapter 9, I think. Yeah, this part. Okay, if you look at the graph, so if our object is at its origin, then it starts from 0. Okay, so if you go to the positive part, okay, if you start from a positive, then it will be plus pi over 2. If you start from a negative, then you start from the bottom. That's why you shift the graph. Okay, that's why you shift the y-axis. Oh yeah, like this one. Okay, so imagine you have something that is oscillating. So for the first diagram, okay, for the first diagram here. So this one, your object starts from origin, therefore we have a sine graph. Now the second one, okay, the reasons why I know I have a plus pi over 2 here is because my object is start from the maximum value. Okay, that's why my graph starts from the maximum A. So if my graph is a negative value, then it starts from the bottom. Okay, it starts from a negative A. That's why we shift the axis. If you don't want to use the idea of shifting the axis, you can stick to the idea here. If you have positive pi over 2, then your graph starts from maximum. If you have negative pi over 2, then your graph starts from minimum, from negative A. Okay, that is because of the shape. It starts from 0 degree to 90 degree, and then to 180 degree. This is 90 degree. This is 180 degree, and then to 270 degree. 270 degree at the same time is negative 90 degree, which is your negative pi over 2 radian. So is that clear?
Yeah, clear. When I see the graph, it's clear. Okay.
All right, good.
Yeah.
Okay, so this one, I let you copy it. So if you don't know how to shift the graph, then you look at just the value. If negative, then you start from negative. Okay, if you have a negative here, then you start from negative. If you have positive, then you start from positive amplitude. That would be easier. Okay, that would be easier. But just why I don't ask you to start from amplitude and a negative amplitude, because sometimes questions, they won't give you negative pi over 2. They might give you, now one of the passive questions, they give you negative 60 degree. Then you have to know where is negative 60 degree. Sometimes I think one of the questions, they give you positive 30 degree. Then you have to know where is positive 30 degree. Okay, that's why I don't teach you the idea of using negative amplitude or positive amplitude. I teach you how to shift the graph, that's it. Right? But if you think it's easier for you to memorize the negative, means it start from negative, positive means it start from positive, then go ahead. Tak ada masalah. Okay, tak ada masalah. Okay, so if you're done, you may try questions E. Questions E is very, very similar to this question, but again, it's for Y against time graph. Okay, Y is against T graph. So if you're done with these questions, you may try questions E. So if you can do questions E, if you can get a right answer, then it means you understand the questions. Okay, so let's look at questions E. So I'll go through questions E with you again. So let's see how to solve it. Okay, if you still don't understand, now this is a chance for you to listen it again, for you to look at it on how to solve it again. So sketch a displacement against time graph for particles at at x equals to 1.5 lambda. All right. So yeah. So how to solve it? Again, we're going to start with an equations. So equations given, y is equals to 5 sine 2 pi t minus pi over 2x. So this is the equations given. So the things that we have to do right now, again, we go through the questions. Question tell us now x is at 1.5 lambda. Okay, so how to simplify it? X equals to 1.5 lambda. And from questions A, okay, from A, we know that lambda is equals to, okay, lambda is equals to 4 cm. Okay, lambda is equals to 4 cm. Therefore, okay. So therefore, x is now equals to 1.5 times 4, which is equals to 6 cm. So we're going to plot a graph for when x is equals to 6 cm. So now this is the values of x. So now we're going to sub it into the original equations. In the equations given. So when x equals to 6 cm, we have y equals to 5 sine 2 pi t minus pi over 2 times 6. Okay, so we have y equals to 5 sine, 5 sine, and then 2 pi t minus 3 pi okay, minus 3 pi. So yeah, that's it. Okay, that's it. So what are we going to do right now? We are going to sketch a graph. Okay, we're going to sketch a graph to represent, okay, for a range in between 0 until 2t. Okay, in between 0 until 2t. Now this minus 3 pi, actually you can simplify it furthermore, all right? Because minus 3 pi means your initial phase angle is a 3 pi is a 360 plus, okay, it's 540 degree, all right? You can actually minus 2 pi from the equations. You can actually simplify it into y equals to 5 sine 2 pi t minus pi. All right, actually minus 3 pi and minus pi, it means they are both starting from the same position. Why? Because 2 pi equals to 1 cycle. Okay, 2 pi equals to 1 cycle. So after you minus 1 cycle, they're still going to start from the same position. This one, it tells you where is the object when it first begins, the initial, the starting point. So minus 3 pi means it starts from a place where there is a minus 540 degree before your origin, before your equilibrium position. So minus pi means minus 180 degree before it reaches its equilibrium position. Okay, like the graph that I showed you just now. All right, so like the graph that I showed you just now, negative pi means it's a negative 180 degree. So basically it represents this position. Okay, it represents 180 degree. So basically minus and plus, both of them, they refer to the same position. Okay, minus pi and plus pi, they both refer to the same position. Okay, now let's go back to the question. So now that I have the general equation, let's say this is my equation. Okay, let's say this is my equation. So I'm going to sketch it. So again, I'm going to show you the 3-step method so that you can see, so that you can understand how to sketch a graph for when there is an initial phase angle. So step 1, okay, step 1, I'm going to assume it comes with without initial phase angle. So y equals to a sine omega t. So I have a y against t graph. Okay, where my y is in terms of cm, t is in terms of second. So now I have just a sine function, so the graph would look like this. Okay, the graph will look like this. This is a general shape. Okay, this is a general shape. And then step number 2. Okay, step number 2. What am I going to do now? Because my graph comes with initial phase angle, so y equals to a sine omega t minus pi. Minus pi means that your object starts from a position at a position's negative 180 degree. Okay, so this part actually it represents your initial position. Okay, initial position. So where is initial position? It is negative 180 degree from equilibrium position. So which means now the graph will look like this. So this is your y-axis. This is your x-axis. So negative 180 degree. Now, if equilibrium position, as shown in step number 1, is start from 0. Okay, so if your object reverse, okay, by 180 degree, it keeps moving backwards by 180 degree. So it means you are going to shift your y-axis to the left again. Okay, you're going to shift your y-axis to the left because it moved by 180 degree. Right, so this is 180 degree, it moved backwards. Dia kembali ke depan sebanyak 180 degree. So you have a graph that looks like an inverted sine graph. Okay, inverted. So you shift the graph, you shift y-axis by pi, by 180 degree. So y against t, now you have an inverted sine. So if you look at the equations, does it come with a negative in front of sine? No, then that means we only need 2 steps. If you have a negative sign in front of a sine, then you need step number 3 to flip the graph over. Okay, to flip it over. So in short, the answer for this question, okay, the answer for this question. So now you have a y, this is cm, so this is t second. So I have a 1 cycle, 2 2 cycle because question is asking for in between, a range in between 0 until 2t. So now I have the graph, then I can label it. So this is 5, this is 0, this is -5, and then the period, okay, the period just now is 1 second. So second one, 2t is 2 seconds. Done, okay, that is a graph. That is the graph for questions E. So you have step 1, you have step 2. So step 2, now it tells you what does it mean by -pi. -pi means initial position. So where is it? It starts from -180 degrees. So you imagine the cycle, okay? You imagine what happens in the chapter 9 just now. So negative means it starts from, okay, so this is the things that we're looking at, negative. So means it starts from a negative angle. -180 degree means it starts from 180 degree. So where is the 180 degree? 180 degree means your graph is moving down. Okay, your graph is oscillating in a negative sign position. Right? So that is the answer for questions E. So since it's very similar to question C, I give you 3 minutes to write it down. Okay, before we proceed to the next question.
Madam, can I ask how did the -3 pi became -pi?
Well, because if you rotate the angles by 180 degree, it will be at the same positions as 3 pi 540 degree. That is the same. -pi and -3 pi, they are located at the same position. Just like your 0 and your 2 pi, they are located at the same position.
Okay.
So this is an oscillation at periodic motion, means that your object it keep rotating. So which means there are certain angle where they will locate at the same position. They will be at the same position. For example, your 90 degree, and then 290 degree, and then 590, 440 degree, 450 degrees, sorry. Okay, so every 360 degree, they will repeat at the same position. They will go back to the same position. So pi, 3 pi, 5 pi, 7 pi, they all located at the same position. 0, 2 pi, 4 pi, 6 pi, 8 pi, they're all located at the same position. Okay, so if you are given a value at initial angles, -3 pi, you can simplify the pi. But of course, if you want to keep it at 3 pi, nothing strong. Okay, also can. Kamu boleh kekalkan. Sebab apa? Sebab sekarang kamu ada periodic motion. Periodic motion bermaksud ada angle memang dia akan berada di lokasi yang sama. Okay, kalau kamu buat bulatan, okay, if you do circle, okay, if you do circle. So now periodic motion, it just means that your object, it keep rotating. Okay, it keep rotating in a clockwise direction. So in a clockwise direction, what is going to happen? Okay, what is going to happen? So we have a 0 degree here, 90 degree here, and then 180 degree here, and 270 degree, or we call -90 degree. Okay, so these are the angles that we have. If your object keeps rotating, then all this they will keep repeating. So now I'm going to change it to pi so that you can see it. So this is 0 pi radian. This is a pi over 2 radian. This is pi, and then here would be -pi over 2. All right, this is for the first cycle. If your object keeps repeating, it keeps going on, okay, until it reaches the next cycle, then every position you will just have to add 2 pi, plus 2 pi, okay, plus 2 pi. So plus 2 pi. So if it keeps going on until the third cycle, then plus 3 pi, and not plus 3, sorry, you plus another 2 pi, okay, plus another 2 pi, plus another 2 pi, plus another 2 pi, you plus another 2 pi. So which means 0, 2 pi, 4 pi, they were all located at this position. And then pi over 2, and then 5 pi over 2, 7 pi over 2, they were all located at the same position. Pi, 3 pi, 5 pi, they all located at this position. And then -pi over 2, -3, and -5 pi over 2, -9 pi over 2, they are all located at this position. Okay, so because it's a periodic motion, so it keeps repeating the same angle over and over and over again. So if you have 3 pi or 5 pi, you can actually simplify it to pi. If you have 2 pi, 4 pi, you can assume it is equal to 0 because they are located at the same position. All right, so you want to change it or not, it is up to you. If you want to change it, go ahead. If you want to keep it at negative 3 pi, also can. Okay, also can. Then you just have to move the y-axis by 3 pi. Okay, you move it to the left by 3 pi. You need to add a 3 pi in front of the original graph. So is that answer your question?
Yeah, I get it.
All right, good. Okay. So let's look at the last questions in your exercise 1, I think. Is this the last questions? Oh no, one more. Okay, now let's look at question number 3. A progressive wave is represented by equations y equals to 20 sine and then 150 pi t minus 1.8x, where x is the displacement in cm and t is the time in second and x is the distance in meter. So now you have 3 different quantity in these equations. Okay, you have 3 different quantity in this equation. So you have to be extra careful. So A follow the equation, follow the unit of y. Okay, A, it follows the units of y. So calculate the wave velocity. Now you want to calculate wave velocity. Okay, you're looking at the wave as a whole. So you need to use equation V equals to F lambda. If you want to calculate F, then you need omega because they are one big family. If you want lambda, then you need K. So can we get omega and K from the equations? Obviously we can. So by comparison, so we are going to compare with general equations. Y equals to A sine omega t minus kx. Okay, omega t minus kx. So what are we going to do? So omega equals to 150 pi by comparisons. And k equals to, k equals to 1.8 meter negative 1 by comparison. Okay, by comparison. So k and x, they use the same unit. A and y, they use the same unit. Okay, A dan y guna unit yang sama, k dengan x dia guna unit yang sama. So x meter, k dalam meter juga. If x is cm, then k would be cm negative 1. Okay, cm negative 1. So now what are we going to do? So omega and k, we have it already. Okay, we proceed to the next step where we're going to calculate frequency and lambda. So from omega, okay, we know omega equals to 2 pi f. So it is equals to 150 pi. So frequency is then equals to 150 pi divided by 2 pi, which is equals to 75 hertz. Okay, 75 hertz. So K, we're going to use it to calculate the wavelength. So K equals to 2 pi over lambda. Okay, and then 2 pi over lambda is equals to 1.8. Therefore, lambda is equals to 2 pi over 1.8 meter. All right, you have it in meter. So now that we have frequency and we have lambda, we can calculate the wave velocity. So wave velocity V is equals to F lambda, which is equals to 75 times 2 pi over 1.8. Okay, and then V is equals to 261.83 meter per second. Okay, bukan cm. Cm is for Y and A. But now you're calculating V by using K, and K is in meter. Therefore, our final quantity, final unit is meter per second. Okay, because it follows K. Okay, so it follows lambda, lambda follow k. So V equals to 261.83 meter per second. Now, because question is asking for velocity, velocity again, okay, this is not wave speed, but question is asking for wave velocity. So velocity is a vector quantity, so you need to give its direction. Right? You need to give its direction. So what is the direction? You look at the equation. Equations give you negative sign. Okay, negative sign. So it means V is equals to 261.83 meter per second to the right. Okay, to the right. So for previous questions, the reasons why we didn't state the direction, because question is asking for wave speed. Speed is a scalar quantity. Scalar quantity, you don't need to state its direction. But now you're looking at wave velocity. Velocity is a vector quantity, therefore you need to state its direction. All right? So that's it. Okay, that is questions 4. Very simple. The things that you have to be careful is just the direction. Okay, you need to take notes of the direction. All right, so 1 minute for you to write it down before I proceed to questions 4. Okay, the last questions in exercise 1. All right, so let's move on to the last questions. Questions number 4. So questions number 4, figure above shows a displacement y against distance graph after times t for the progressive wave which propagates to the left. Aha! Questions tells you now it propagates to the left. So you have a wave that is moving to the left. That means you need to form an equation with positive sign. Okay, so the direction is to the left. Now, actually, it will be better if you show the directions in the graph, okay, in the graph that you sketch, or the graph given. They sometimes they will come with the directions. So you look at the arrow, okay, the arrow will tell you the directions of the propagation. So in this case, your graph is propagates to the left with a speed. So this is your v, okay, v is equals to 20 cm per second. So determine the wave numbers and the frequency of the wave. Wave number is k. Frequency is f. So wave number, now you are given y against x graph. So y against x graph, which tells you you can get period. Okay, you can get period from the graph. So for y against graph, the information that you can get is a and also t, capital letter T. So if you look at the graph given is 2 cycle, okay, which means the t is your 2 cm. All right, after 1 complete cycle. So this is 1 complete cycle. So after 1 complete cycle, the values given along the x-axis, that one is your lambda. Okay, so this is your lambda. So given lambda equals to 2 cm, and we know k is equals to 2 pi over lambda. So k is equals to 2 pi over 2. Therefore, I have a k equals to pi m negative 1. Okay, pi m negative 1. Pi cm. Okay, pi cm negative 1. So when it comes to speed, okay, now why? The reasons why I keep it in cm, okay, that is because when it comes to v, I also need to calculate it in cm. All right, so v equals to f lambda. V given is in cm. You need to be extra careful with the unit. So v given is in cm. So I have 20 equals to f. So my lambda should be kept in cm. That's why I don't want to change any of the unit. All right, because everything is given is in cm. That will be easier for you to solve it if you keep everything in cm. So of course you can change it to meter, nothing wrong. If you change it to meter, then you are going to get K equals to 100 meter per 100 pi per meter. Okay, so this is K in meter. Okay, so now my lambda is 2, therefore my frequency 20 divided by 2, cm divided by cm, therefore I have 10 hertz. Okay, so if your V is in cm, lambda should be in cm. If your V is meter per second, then lambda you need to change it into meter. Make sure the unit is consistent. Now, when we talk about unit in your assignment, there are quite a lot of you who didn't state the unit, who gave the wrong unit. So mark will be deducted. Okay, ada orang yang markah kena tolak disebabkan unit. So if you make mistake in unit, then that is not acceptable. But if there's any other minor mistake, I will just assume I didn't see it. Okay, but unit cannot. Okay, unit must be a right unit. Okay, I cannot ignore it if you got the wrong unit. But for some other minor mistake, okay, I will just accept it. All right, so I think you can see the marking in the Google Classroom already. So some of you did very bad. Okay, I think the worst in this class is you got 1/10 in your assignment. Okay, 1/10 in your assignment, and I cannot do anything because you are given plenty of time to do it. Okay, I allow you to submit draft for me to check it before you do your final final answer, before you submit your final versions of answer. I say you can discuss with your friends, and yet you still score 1/10. Then I cannot do anything. All right, that would be your final score. So okay, now that one, leave it first. You can check Google Classroom after this lesson, after class. All right, but the score is not final yet. You need to wait for second marker. Okay, second examiner to mark it first. So the things that I accept, I assume is correct. Maybe second marker thing is wrong, so the marks might be slightly lower, or it might be slightly higher. Maybe the things that I think is wrong, but second examiner thinks, well, I can accept it. They can accept it. Then we will adjust the score. Okay, so you can have a look, but that is not your final score yet. Okay, now let's go back to questions 4b. Okay, write an expressions of a displacement as a functions of x and t for the wave above. So now these questions ask you to form equations. How are you going to form the equation? Of course, you need to start from the general equations. So general equations, y is equals to a sine omega t. Now plus or minus, according to questions, you need to use a plus sign. So if sign is wrong, then it means your answer is wrong, even though the rest of the values, they are all correct. Okay, so y equals to a sine omega t plus kx. This is the general equation, and it must be in a positive sign because the question tells you it propagates to the left. So y equals to a sine omega t plus kx. The things that you need to substitute when it comes to this equation, the value that is constant is your a, your omega, and the k. Okay, these three values, they are constant in this equation. There are no changes. Okay, they are not changing because of the changes in the time or in the distance. So they are fixed. So it means we need to substitute these three values in our equation. So according to the graph given, we have a equals to 6 cm, and then we have a lambda. Okay, lambda in 2 cm, and k is equals to pi cm negative 1. And the things that we don't have right now is omega. Okay, but can we calculate omega? Yes, we can. Why? Because we already have frequency in questions A. So frequency and omega, they are one family. So from here, you can then determine the values of frequency. So omega equals to 2 pi f. Okay, which is then equals to 2 pi times 10. So omega is equals to 20 pi radian per second. Okay, 20 pi radian per second. So now I'm going to substitute all of them into the equations. So I have y is equals to 6 sine 20 pi t plus, okay, plus pi x. So this is my equation. And of course, you need to state the unit. So where y and x, okay, y and x, they are in second, okay, are measures Okay, are measures in cm and t in second. All right, so you need to state so that people know this 6 actually represents 6 cm, not 6 meter, and this pi is in terms of a cm as well because your x is in cm. Okay, are measured in cm. So if it didn't state, then the examiner, it's up to them whether they want to give you a right or wrong. Okay, if they assume they understand, then they can give you a right. If they assume they don't understand, then they can mark it as wrong. So it's a very subjective. Okay, it depends. It depends on the examiner. So it will be better if you state this statement. Okay, you include this statement in your final answer. So if you look at some of the books, some of the video from other class, most of them they didn't state it. Okay, because they assume the examiner know. But for me, I think it will be safer if you state it. Why? Because sometimes examiner they don't know whether you're writing your answer in terms of cm or in terms of meter. Okay, they can assume they don't know. Right, so it will be better if you write it down. So that is the last questions in the first exercise, and we have only half an hour for a second exercise. Do we have enough time to solve it? No, I think we don't have enough time to finish exercise 2. So I will keep exercise 2 and exercise 3 for tomorrow. Okay, tomorrow we definitely can finish both of them in 2 hours. Okay, so yeah, I think I will leave it for tomorrow. So that's all for today. Okay, do you have any questions that you'd like to ask? Ada sebarang pertanyaan yang kamu nak tanya regarding the today exercise, regarding the 4 questions that we discussed today? No? Okay, if no, then that is good. That's all for today. You may leave the class.